All right. Well, hopefully you made it through that TED Talk and you saw her inferences from the data on dendritic differences between male and female rats who were exposed or not to, stress in the womb. So I wanted to show you the actual one of the actual studies that she was referring to. Like the picture that she showed in the talk came from this actual study. And what I wanted you to see is, okay, so you've got the dendritic spines on the y-axis, and then you have male and female rats on the x-axis. And in the blue bars were the rats that were exposed to stress, and in the gray bars are the rats that weren't exposed to stress. What I want you to notice first off is that for the females, there's not much change. Whether they are exposed to stress or not much happens to the developing brain. In fact, if you see in the no stress condition, the females have somewhat more dendritic spines than the males do, but not a ton more. Like it's probably statistically significant, the amount of excess spines in the no stress females versus the no stress males. But just looking at this chart, you're not seeing a lot of difference. And the reduction in the amount of spines for the stressed females versus the no stress females, that's also a significant difference statistically. But again, it's not as big of a drop as you see in the males who are exposed to stress. So if you have a male who has, experiences stress in the womb, the dendritic growth is not just to make it more of a feminine pattern, it's well beyond what the feminine brain would have been in the absence of stress. It's well beyond that. So this is, it's hard to interpret what that means to have, it's not just a feminizing of those spines. It's like doubling the amount of feminizing that would happen in a no stress female. So it's hard to interpret exactly what that would do to that male's behavior. It's hard to know what that would mean because we don't have an analogy called, well, it just like, because females don't look like that. So it's like a hyper feminization of the male brain. It's not just feminization. And so we're not exactly sure. Sometimes when you have a pattern that is hyper masculine or hyper feminine, it actually kicks you over to the other side and you're back to just sort of masculine behavior, or just sort of feminine behavior. So it's hard to say what exactly this would do. I wanted to have you see this graphically. She did not show this graph. This is the actual graph from the study that she was talking about, but she chose to show us the dendrites, not the actual pattern, because I think it's really interesting to see that the females are not that affected by stress. They show a slight reduction, but not that much. The males are really affected by the stress. So we don't know, for one thing, if this is the pattern that would even happen in males of humans. And if it does, what exactly that would mean. To have even more dendritic spines than you would expect to see in a no stress female. So we don't exactly know what it means. So the other thing that's important to keep in mind with regard to what she talked about in that piece is that this study and the studies that she talked about were looking at a very specific area of the brain. It was looking at the hippocampus and nothing else. And that's one little tiny region. We're not sure whether this kind of dendritic spine changes would appear in other parts of the brain. And we're not even sure whether any kind of sex-related behavior comes out of the hippocampus. There's a possibility, there's a certain amount of memory that's based on the hippocampus. I mean, it's where things are stored temporarily before converting into long-term memory. So maybe having a feminized hippocampus would give a male rat like really good memory, at least temporary memory, short-term memory. Maybe that would be one effect, but we're not sure whether other parts of the brain that are known to have sex differences in them are affected by stress. For example, the band of fibers that connects the two hemispheres, the corpus callosum, is much bigger and more densely packed in females than in males. It's one of the things that allows for females to have so much crosstalk when they're experiencing, the same exact thing that a male has. Males will tend to use one hemisphere to be assessing a situation. Females are much more likely to use both of their hemispheres when assessing a situation. Part of that is because females have bigger corpus callosa. So we don't know if stress impacts the shape or density of the corpus callosum, which is a known sex difference. or if the language areas that are, again, another known sex difference, if those are impacted by stress, or if the spatial areas of the brain are affected by stress. We're not clear on that. So you have to be really super careful. What she said sounded logical, but it was definitely extending what we know beyond what we actually know. So I just wanted to kind of clarify that stuff. Okay, so I had put male female differences with a question mark on the previous slides. Now in this section we're going to have an exclamation point. Like, these are really well known, well confirmed, consistent differences that we see between males and females. One, males have better spatial skills than females on average, very consistently across all cultures, across all the time since we've been measuring this. Males have better spatial skills. And there's a very strong evolutionary argument for why that might be true, because males on average are the ones who would, sort of leave the village or, the settlement and go out and hunt, and they had to be able to find their way back. They were the ones who had to be able to recognize at a distance a prey animal versus a predator animal. They were the ones who had to figure out whether the animal was close enough to throw their spear at or not. Like, a lot of very basic spatial skills are dependent on, like, our ancestral history and the division of the sexes that used to occur. And a lot of the skills that males have are still representative of that today. Spatial skills are very consistently, on average, better in males than females. Now, there are some females with amazing spatial skills, and so we're not trying to say females can't have good spatial skills. We're just saying that on average, the group of males tend to score better on tasks like what you're seeing in front of you, which is called a mental rotation task. You're shown a three-dimensional object, and then you're shown a two-dimensional depiction like what you're seeing on the screen. And you're supposed to say whether the thing that's on the screen is the three-dimensional object just rotated. And males tend to be faster at that and more accurate at that. Females tend to have better verbal skills. All different ways of measuring it, whether you're talking about vocabulary or spelling or grammar use or, any kind of measure we know of for, the ability to come up with synonyms, just anything that you could think of for measuring verbal skills, females tend to be better at than males on average. Now, if I take two people, one's male and one female, and I make them do one of these tasks, I have no way of knowing which one will actually be better in this particular task right now between the two of them. I can't say that. All I can say is that on average, if I had to guess, I would make a prediction that the male will do better at the spatial task and the female will do better at the verbal task, because on average, I have a chance of being right. But I can't say for individuals. I don't know. Males on average are more physically aggressive than females are. That's why I have a little picture of fisticuffs going on here with these Rorschach ink blot creatures. Males on average are more physically aggressive. Females are more verbally aggressive. Females are more likely to use social aggression, where they say, I won't be your friend anymore, or they socially isolate people. Males are more physically aggressive, though, and that's from a very young age. We see differences between male and female behavior, so you can't just blame testosterone, because little children don't really have differences in their hormone levels, and yet males tend to be more physically aggressive than females. We see it across cultures, we see it across time, so this is a very consistent difference between males and females. Females are much better communicators, and that includes at interpreting nonverbal language from the whoever they're talking with. They pick up on facial expressions and body postures and gestures that oftentimes males don't detect. Females do a better job of expressing their own mental states through verbal means as well as through physical means, like, with facial expressions and so on. So on average, females are better at sending and receiving verbal and body language, communications. So these are very consistent differences that we see between males and females. Now, this next video that I want you to watch is from an old show called Brain Games that used to be on National Geographic. It was awesome. Had all sorts of psychological tests of things. And in this case, they're going to give you an example of differences in memory between males and females that are pretty consistent. So go ahead and do it. And the thing that's fun about Brain Games is if you play along, and try and, you know, do the task as he asks you to do them. You'll get some insight into difficulties or skills that you might have as well, and see whether you're illustrating what they're claiming. So I'll see you on the other side of this video.